And hello. Today we'll be continuing with sets and we'll be looking in particularly at set notation. So what do I mean by notation? I mean the symbols that we use and what do they mean. So you've probably heard me mention multiple times about elements. So here is a set A with elements 1, 3, 5, 7. And then I'll show you this 5, and then we have this kind of E, this kind of strange looking E, and then we have A. And then I'll show you another one. We have 2, then E with a line through it, A. So even if you just thought about it, what do you think it means? We're talking about elements. Well, simply, it just means 5 is an element of A. So 5 is in this set. Yeah, it's right there. 5 is in A. 2, what do you think the line through means? Well, it's not. It's not an element of A. So 2 is not in this set. So that's your first kind of notation you have to know. E, so 5 is an element of A. 2 is not an element of A. So the way I try to remember it is the not part is with the line through it. And E, I think of element. E for element. Intersection. So you would have heard this before when you were looking at Venn diagrams. So in one of my other videos, I was talking about Venn diagrams and I gave this example. So the intersection would be for these two sets. What do they have in common? So this little bit in the middle. 2 and 4. Because look, 2 and 4 is in A. And 2 and 4 is also in B. So I'll give you a different example. Let's say the intersection of these two sets. So mom, dad, brother, sister, mom, aunt, uncle, dad. What would be the intersection here? Well, it would be mom and dad, because mom and dad is in A and mom and dad is in B. And the symbol we use is this symbol. It's like an N. N for intersection. So A intersection B. A and B have stuff in common, or the elements that are in common. What are those elements? Mom and dad. So intersection, what A and B have in common. So this symbol here is for intersection. And remember, if you were to do it on a Venn diagram, if I did mom, dad, brother, sister, so mom, dad, brother, what do they have in common? Well, what's the bit in the middle where the two circles cross? So if you're not comfortable with that, look back at the Venn diagrams and go over them. Okay, next thing would be union. You might have heard the word union before in other ways, not in mathematical ways. So if two people get married, it's the union of two people coming together. You might have a workers' union, so a bunch of workers all coming together to kind of form their own group. And it's similar in maths. So I have A here, 10, 8, 6, 2, 4, and B, 1, 3, 5. And then I have this. A, this symbol B, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, you'll notice that's just all the numbers on this Venn diagram. So what union means is just all the elements in A and all the elements in B. And you just list them out. So 1, 2, 3, 4, 5 is in B. 10, 2, 4. Now, I've already put it in 2 and 4. I don't need to double up. 8, 6. Those are all the elements that are on the Venn diagram. So A and this U for union B just means add everything up that's on the Venn diagram. So set A and B combined, and there's no repeats. So don't have 2 and 4. You don't write them down twice. So yeah, it would be everything in the two circles. Complement. So not a compliment you would give to a person. I'll use an example just to explain what complement is. It's actually quite easy. Here's a set A. Mom, dad, brother, sister. Set B. mom, aunt, uncle, dad. So if you were to fill them in here, just think about first, where would you put? So what do they have in common in the intersection? Okay, mom and dad, those are both in the intersection. And then in set A, I'd have brother, sister, and then set B, I'd have aunt and uncle. Okay? Now I have A, and then I have a little kind of dash is equal to aunt, uncle. So what does A dash mean? It means everything outside of that set. So everything, this whole set, mom, dad, brother, sister, that's set A. If I got rid of that, everything outside of that. So on the Venn diagram. So visually it looks like that. If I got rid of all that bit in there, what's left? So I got rid of all of this. What's left over here? Well, it would be aunt and uncle. Now, why did I pick aunt and uncle? Why is mom and dad not included? Because look, that's in set B. Because mom and dad is in set A. I can't include mom and dad. So anything in A is not going to be in B. Anything in A, I can't include in A complement. A complement is everything outside of that set. So I've cut out A. Imagine I picked up that A circle and I cut it out. Anything that's left over in B, that's what A complement is. So complement just means anything outside that set. Anything that's not in that set. And that's all the notation you have to know. Union we talked about. Intersection. Subset, I've already done a video on that. This is the empty set or the null set. Remember, it's just the two brackets. It's a zero set, nothing's there. Element, not an element, and then not a subset. We wouldn't really see that, but you might come across it. And then we looked at complement as well, just there at the very end. So yeah, you need to remember all this. You gotta learn it, I'm afraid. But it's not too many, and I think if you practice it a little bit, you'll just remember it off the top of your head. Okay, I'll give you a few seconds to pause the video and just do the recap questions. So I have set A and B here. What's A intersection B? And then I have brackets around it. Complement. Okay, so let's forget about the brackets and the complement. What's A intersection B? What's that mean? The N. Intersection. It means everything they have in common. So what do they have in common? They have -5 in common. They have 8 in common. And they have 1 in common. Yeah? So I have -5, 8, and 1. A intersection B complement is everything outside of everything outside of A intersection B. So imagine I cut out A intersection B. I cut out -5, 8, and 1. Got rid of them. Threw them in the bin. Everything else outside of that, that's included here. So I have 9. No, I've thrown away -5. I've thrown away 8. 6. I can do that. Thrown away 1. Thrown away -5. I have 4. I have 3. I've thrown away 8. I've thrown away 1. So it would be 9, 6, 4, and 3. That's everything excluding A intersection B. Okay? Next bit. True or false? A union B is equal to A plus B minus A intersection B. So I'm using these bits over here. Okay, so we'll start off now and do it step by step. A union B first. What's A union B? It's all of these combined. So it'll be 9, -5, 8, 6, 1. I've already said -5, 3, 4, 3. I've already said 8. So it's all this list here. 9, 8, 6, 4, 3, 1, -5. Okay, let's do it step by step. What's A plus B first? So that's everything in A plus everything in B. So I'd have 9, -5, -5. So I have 2 -5s, which is a bit of a problem. I have 8, 8, 2 8s. I have a 6, 4, 3, and I have 2 1s. So all I've done is just listed out everything here plus everything there. But we have a few problems. First off, we have repeats. Yeah. Repeats, they're not a set. In a bit of trouble. Can't do that. But that's just A plus B. What about A plus B minus A intersection B? What's A intersection B? Well, I found it out over here, yeah? Minus 5, 8, 1. So if I took out a minus 5, an 8, and one of the 1s, so that means I got rid of one of these minus 5s, I got rid of one of these 8s, and I got rid of one of the 1s. What am I left with? Well, I'm left with 9, 8, 6, 4, 3, 2, 1, minus 5. And look, that's the exact same thing as A union B. So this little rule here is another rule you got to remember. A union B, it's just A plus B minus the intersection of A intersection B. That's something, again, you got to know. You'll be seeing it used in different questions in different contexts. But that's kind of like a proof we did there for it.